negative 2, and I have the line v equals negative u. How am I going to graph that? Line needs the points, right? To graph a line, normally I use points on it. So how am I going to get some points to graph this from? What values can I plug in? Negative 2 and negative 1, right? That's what u is restricted between, so let's do it. I'm going to plug in negative 2 for u, and when I plug in negative 2 for u, what is v? 2. Let's look here. 1 point right here. I now plug in negative 1, and when u is negative 1, what is v? 1. So I'm going to do that. I'm going to go ahead and graph that. Put it in green so it lines up. Right here. So u, right? V is equal to negative u. And that came directly from x equals 0. Question. That's good? Okay. We only did one of them, right? We've got to do a couple more. You're going to notice that the next one we do looks very, very similar. Let's go ahead and look at y equals 0. All I'm doing is I'm running through my 4 bounds. When you're at this homework, you only have 3 bounds. You only actually have to do it 3 times. We're going to do it all 4 though. This one is going to look really similar to the one we just did, so I want you to try it. I want you to try finding what is y equals 0 going to translate over into. And despite what you may believe, I did not mean peaceful crushing. I do apologize that it was really rough. I also apologize that I don't respond to emails this weekend. When I say all of my stuff is in Texas, I mean all of my school stuff, including my computer. So, I apologize. I'm trying to keep it really nice, so that's really nice steps. First thing you should do is you just plug it back into the original, right? What we originally came up with. You'll get u equals x and v equals x. Does that look right? Good. Okay. Second thing you're going to do is eliminate the x's so that u and v are expressed solely in terms of each other. I get u equals v. The next thing I'm going to do is keep in mind any restrictions I have. What restriction did we have when we were looking at y equals 0? I had x is between 1 and 2, right? And that's because it came from right here. So if x is between 1 and 2, and if x is in between 1 and 2, what is u going to be in between? 1 and 2, right? Because I have x equals u, so the same restriction is going to hold. All I have to do now is come over and graph this. Where is this line going to start for me? It's going to start at x equals 1. Sorry, u equals 1. And what will v be when u is 1? 1, right? So u equals v. Okay. Where will the line end? 2. And what v value will it end at? Okay. So what I can see, I have right here, v equals 0. questions on how I found them? Now, you probably have a pretty good idea of where my next bound is going to be, but we should really find it just in case. Weird things have happened. And so to find the next two, I just need to look at the other two lines I have. Which two am I missing? What's the next one I have to translate over? Okay, y equals x minus 2. What do we think? Does that look okay? Okay. Let's see here. Now my original equation, this is what I'm trying to translate. Or transform. First thing I have to do is go back to my original. My original was u equals x plus y, right? What am I going to do? Last time was really easy, right? Because we just plugged in 0 for y. What am I going to be plugging in for y this time? I have this information right here, right? I'm just going to go ahead and plug that in. That is, this equation, when I translate it over, will be u equals x plus x minus 2. Or u equals 2x minus 2. Look okay? Now that was just my first original equation, right? I also have v. You guys are going to have to remind me, is v equal, is it x minus y or y minus x? X minus y, sweet. So when I plug in, v equals x minus x minus 2. What do you think? Okay? Any questions? Looks good? I think I'm going to get 2 out. Okay. So I have to think about this here. Right now, I know I have the equation v equals 2, right? That's the important one because what does v equals 2 look like? Horizontal line going straight across, right? I know this is going to be a horizontal line going straight across, which means this part is just going to tell me what values I can be between for u. What I need to do now is go ahead. I already did 2 steps at once, right? I need to go back and look at my restrictions. What type of restrictions do I have on that bottom one there? We didn't write any, right? How come we didn't have to write any for that diagonal right there? Why didn't we write y is between or x is between for the diagonal? We wrote it over here, right? We wrote it right here. Why didn't we write it for these two? Because we had hit our other bounds, right? We already knew where we were stopping. The same kind of logic can be applied right here. I know I'm looking at v equals 2, right? V equals 2, where am I going to stop when I draw this across? I don't know. V equals 2 is here, so we'll go ahead and do the red so we can see where it translates over to. Here and there. If you want to have a more rigorous proof of why this works, you could bound one of them right here. That is, you could say, you know what, looks like y is between -2 and 0. And then translate your bounds over and look at what happens that way. However, we know since we're looking at a bounded area, and we talked about last time, the boundary goes to the boundary. We're looking at a closed solid here. Okay. This is one of them. Let's talk about the other one. I have one more I need to do. That is y equals x minus 1, right? Final one. Do you really need to find this? What do you think? Do I need to do the whole thing, find it? Probably not, because in reality, I know a lot about what this is going to look like. I know a lot about what it's going to look like because I noticed that the functions I'm using to transform over are linear, and my original bounds were linear. There's nothing squared or nothing weird going on here. So I know it's going to be a straight line, but just in case. U equals x plus y. I'm going to go ahead and sub in. U equals x plus x minus 1. U equals 2x minus 1. U equals x minus y. like my x's are going to cancel out, I'm going to get 1. I did it pretty fast. Are we okay with how we did it, though? Your question? No? Okay. What is this going to look like? Straight line, kind of close off the bottom, right? Just like that. Questions on how I found these values? Really quickly, my new bound. 1 equals 2, and the 2 functions on the side. Now the whole point of this is to go ahead and set up my new integral with the transformation. In order to set up the new integral with the transformation, though, we need to find one more thing. What's the next thing we need to find? The Jacobian, right? What step are we on? I think we're on step 4. You guys haven't told me it's not step 4, so that's what we're going to go with. We got to find the Jacobian. The Jacobian is equal to the determinant of some matrix, right? The matrix is of the partials. What partial do I take first? Partial of x with respect to u, right? Partial in my xy plane with respect to the first variable in my uz plane. And partial of x with respect to z, partial of y with respect to u, partial of y with respect to z. That's good? No question? No? Fantastic. Well, you guys don't talk to me. I guess the least I can do is make you do some matrix algebra, right? I want you to find the determinant for me. Don't overthink it. You're going to need those functions of x and y, right? That's how we found those. That's how we isolate them. I can't remember. X was equal to 1/2. What was it? And then y would u minus b? Yep. This is actually a pretty fantastic thing to take partial derivatives of. What's my first partial going to be? 1/2, right? Because I'm going to take this with respect to u. B is a constant, it drops off. U goes to 1, I get 1/2. Awesome. What's my second partial going to be? 1/2, there's a lot of diversity in this one. First partial of y with respect to u, 1/2. My next partial is negative 1/2, right? There's your excitement for the day. Okay, so I take the determinant, I multiply on the diagonal, 1/2 times negative 1/2, right? Give me negative 1/4 minus the other diagonal, negative 1/4, so it's going to get negative 1/2. Now the one thing we didn't talk about last time is that when we take these volumes, when we're taking these double, later triple integrals, we need to make sure that this Jacobian has 2 properties. First of all, this is only going to work if the Jacobian is non-zero. It cannot be 0. Why can the Jacobian not be 0? Why would that suck? Why would it invalidate everything? Because we're trying to find some type of volume here, right? We're trying to find some type of measurement of space. And if Jacobian is 0, what is the integral going to be? 0, right? So we got to make sure the Jacobian is non-zero. We also need to make sure we can find the Jacobian. Well, in order to find the Jacobian, what do we have to be able to find? The partials, the first order partials, right? Which means all of this junk only works if our transformation is, we had some vocab last time. We talked about if it has continuous first order partial derivatives, it is what? Continuous first order partial derivatives. We had some notation. No, 1-to-1 means you can do it inverse. There's fancy.